Hello again. Here we are finishing page 2 on unit 10, section 3 of solving exponential and log equations. So this is the last example we did, so we have 3 more on page 2. So first thing we're going to do in this question right here, we need to isolate the term containing the exponent. So I need to start out by dividing by 5 on both sides. So divide by 5 on both sides, I have 2 to the power of 3x equals 4, because 20 divided by 5 is 4. Okay, now I'm going to rewrite on this 4 with base 2. So because I know 2 squared is 4. So 2 to the power of 3x equals 2 squared. So now that the bases are the same, the exponents are the same. So 3x equals 2. Divide both sides by 3, I get x equals 2/3. Easy. Notice that I could not rewrite this until I had the term containing the exponent fully isolated. So you had to divide by 5 here first. Same idea I have to do for this one. I need to start out by dividing both sides by 2. So then I have 8 to the power of 2x plus 1 equals 64. And I know from the get-go 64 is just 8 squared. Easy for me to rewrite this with the same base, and the base is going to be 8. So 8 squared. The bases are the same, exponents are the same. So 2x plus 1 is 2. Minus 1 on both sides, I get 1 right here. And then divide by 2, I get 1 over 2. Now a log function. We need to isolate this before I can go ahead and rewrite this in exponential form. So minus 5 on both sides. So log base 10, because I don't have anything, so that's known to be base 10 of x minus 3. So minus 5 on both sides, I get 2. So now go ahead and rewrite this. The base is always the base. So 10 to the power of 2 equals the argument, so x minus 3. 10 squared is 100. Add 3 to both sides, so x equals 103. So now here's some strategies for you to use when you have to solve those equations. If you need to pause this to copy that on your paper, if that doesn't make sense to you, ask me questions, but we're moving on. So we need to solve each of the following equations for x, give the exact values, then give a decimal approximation with 3 decimal places. Okay. So you can do this, the first one, in 2 different ways. I'm just going to multiply both sides by log base 2 so I can simplify this. If you want to do this by rewriting, 32 is 2 to the power of 5. That's fine too. Let's do that. Why not? Because I just talked about it. So 2 to the power of x equals 2 to the power of 5, because 32 is the same thing as 2 to the 5th power. So bases are the same, exponents are the same, so easy, x equals 5. Okay, now I'm going to use the properties here to rewrite as a single natural log equation right here. So this minus means I'm going to have to divide the arguments, leaving me with natural log of x over 3 equals 0. I also know natural log is log base e. So I just rewrote that. So now I'm ready to rewrite this as an exponential form so I can solve. So e to the power of 0 equals the argument, so x over 3. Anything raised to the power of 0 equals 1, so I'm going to continue right here. So 1 equals x over 3. Now I multiply, x equals 3. Right here, I need to divide both sides by 3. So 2 to the power of x is 42 divided by 3 is 14. There's not an exponent that I can choose to be able to rewrite 14 as base 2. So in this case, I only have one way to go about this question. And that way is I will multiply both sides by log base 2. Why did I do that? Well, when the base and the arguments are the same, that equals 1. And that x will go in the front, multiplying. So I would write yourself a little note right there that log base 2 of 2, that equals 1. It doesn't disappear. That equals 1. So now the x goes in the front multiplying. So x times 1 is x. So I have log base 2 of 14. But then we need to write a decimal form in 3 decimal places. So let's go ahead and put this in the calculator. So I have log base 2 of 14. So 3.807. Okay. I know natural log is log base e of x equals negative 3. So we're going to rewrite this. So e to the power of a negative 3 equals x. So let's go ahead and put this in the calculator. So e to the power of negative 3 is that. 3 decimal places will be 0.0. That'll make a 9, a 0, 5, so 5, 0 right there. 3 decimal places. Okay, so this one, we need to do a couple things before we can rewrite this. So first, I will add 4 to both sides. So 11 plus 4 is 15. Then you divide by 2. So I have 3 to the power of 2t minus 5 equals, again, plus 4 on both sides. That makes this 15. 15 divided by 2 is 15 over 2. Okay, there's nothing I can do to rewrite 7.5 as base 3. So I'm going to follow the same idea that I did to this one. So I will multiply both sides by log base 3. So now base and arguments are the same. That means the exponent is going to go in the front multiplying. So I have 2t minus 5 times 1 equals log base 3 of 15 over 2. I'm running out of room. So to isolate this, I need to add 5 to both sides and then divide that by 2. So t equals log base 3 of 15 over 2 plus 5, everything divided by 2. Now to write this in 3 decimal places, I have log base 3 of 15 over 2 plus 5 divided by 2. That's what you put in the calculator. So 3.417. This one is easy. No base, that means the default is base 10. So let's go ahead and rewrite this so when you go back to your notes, you know where that 10 came from. So you're not asking me how the magic happened. So now you're going to rewrite this in exponential form. So 10 to the power of -1 equals x. So x is equal to 1 over 10, or x equals 0.01. If you don't know this, put it in the calculator. I hope you do. Okay, so -5 on both sides. So now you have e to the power of x equals 2. Now we're going to multiply both sides here by natural log, because natural log is log with the base e. And I also know natural log of e equals 1. Okay, I said a whole bunch of things. I didn't write anything down, but I hope you were listening. So natural log of e to the power of x equals natural log of 2. This equals 1. This x goes in the front multiplying. So x equals natural log of 2. And then this in decimal place is natural log of 2, 0.693. Last one. So now I see this minus right there. I think division. So I need to divide the arguments. So log base 6 of 3x plus 14 divided by this argument right there. That argument is 5 equals log base 6 of 2x. Okay, now I have log base 6 on both sides. If the log bases are the same, the arguments are the same. So 3x plus 14 equals 5, over 5 equals 2x. Multiply both sides. I have 10x right there. So now take away 3x from both sides. You get 7x equals 14. Divide both sides by 7. You get x equals 2. And then just quickly check. It's a positive number. 2 times 2 is 4, so positive number right there. So that checks, because remember, we cannot take the log, find the log of a negative number or 0. So let's plug that in right there for x. 6 plus 14, that's 20. So positive 20, that checks. No extraneous solutions on that one. I'll see you next time.